Trigonometry is a branch of mathematics that deals with the relationships between the angles and sides of triangles. It's a fundamental tool used in various fields such as physics, engineering, astronomy, and more. Trigonometry involves the study of trigonometric functions like sine, cosine, tangent, and their inverses. Trigonometric functions. Sine, sin. The sine of an angle in a right triangle is the ratio of the length of the side opposite the angle to the length of the hypotenuse. Cosine, cos. The cosine of an angle is the ratio of the length of the side adjacent to the angle to the length of the hypotenuse. Tangent, tan. The tangent of an angle is the ratio of the length of the side opposite the angle to the length of the side adjacent to the angle. These functions are commonly used to relate angles and side lengths in right triangles. Applications of trigonometry. Geometry. Trigonometry helps solve problems involving triangles, such as finding the lengths of sides and measures of angles. Physics. Trigonometry is used to analyze motion, forces, and energy. For example, when an object is launched at an angle, trigonometry can help predict its trajectory and range. Engineering. Trigonometry is essential for designing structures, analyzing forces in mechanical systems, and calculating electrical circuit values. Astronomy. Trigonometry is used to determine distances between celestial objects, their sizes, and positions. Navigation. Trigonometry helps determine distances and directions. Art and animation. Trigonometry is used in computer graphics and animation to create realistic movements and angles. Music. Trigonometric functions like sine and cosine are used to create and analyze sound waves in music. Example, calculating heights using trigonometry. Imagine you're standing some distance away from a tall building, and you want to know the building's height. Let's say you measure the angle of elevation, the angle between your line of sight and the ground, to the top of the building. Given, angle of elevation equals 30 degrees, distance to building equals 100 meters. Use the tangent function. Tan, angle, equals opposite, adjacent. In this case, the opposite side is the height of the building, and the adjacent side is the distance to the building. Tan, 30 degrees, equals height, 100 meters. Solve for height. Height equals tan, 30 degrees, asterisk 100 meters approximately equals 57.74 meters. So, using trigonometry, you've determined that the building's height is approximately 57.74 meters. The law of cosines is a mathematical theorem that relates the lengths of the sides of a triangle to the cosine of one of its angles. It's particularly useful for solving triangles that are not right triangles, where the Pythagorean theorem cannot be directly applied. The law of cosines is an extension of the Pythagorean theorem and provides a more general way to find side lengths and angles in triangles. Mathematical statement. For any triangle with sides of lengths A, B, and C, and an angle C opposite the side C, the law of cosines can be expressed as 2 equals 2 plus 2 minus 2 cos, C2 equals A2 plus B2 minus 2 ab. Operator cos, C. Where 1. A, B, and C are the lengths of the sides of the triangle. 2. C is the angle opposite the side C. Key concepts. Triangle. The law of cosines applies to all types of triangles, whether they are acute, obtuse, or right triangles. Cosine rule. The law of cosines is often referred to as the cosine rule, and it provides a way to find an unknown side length or angle in a triangle when you know the lengths of two sides and the measure of the included angle. SAS, side angle side. Criterion. The law of cosines can be used to solve triangles when you know the lengths of two sides and the measure of the included angle. Applications. The law of cosines has practical applications in various fields, including trigonometry. The theorem is used to calculate side lengths and angles of non-right triangles, often in conjunction with the law of sines. Navigation. It can be used in navigation to determine distances or directions between 2 points on the Earth's surface. Astronomy. It's used to calculate distances and angles in celestial observations. Engineering. The theorem is applied in engineering for designing structures, calculating forces, and determining distances. Physics. The law of cosines is used in physics to analyze the motion of objects in non-right triangle trajectories. Surveying. It's used to measure distances and angles when creating accurate land surveys. Example, applying the law of cosines. Consider a triangle with sides equals 7a equals 7, equals 9b equals 9, and an angle equals 50 ring operator C equals 50 ring operator. We want to find the length of the third side C. Using the law of cosines. 2 equals 2 plus 2 minus 2 cos, C2 equals A2 plus B2 minus 2 ab. Operator cos, C, 2 equals 72 plus 92 minus 2. Operator 7. Operator 9. Operator cos, 50 ring operator, C2 equals 72 plus 92 minus 2. Operator 7. Operator 9. Operator cos, 50 ring operator. Calculating the values. 2 equals 49 plus 81 minus 126. Operator cos, 50 ring operator, C2 equals 49 plus 81 minus 126. Operator cos, 50 ring operator. Solving for C. 2 equals 130 minus 126. Operator cos, 50 ring operator, C2 equals 130 minus 126. Operator cos, 50 ring operator, 2 approximately equals 40.96 C2 approximately equals 40.96 approximately equals 40.96 C approximately equals 40.96 approximately equals 6.4 C approximately equals 6.4. So, in this example, the length of the third side C is approximately 6.4 units. The law of cosines is a versatile tool that enables the solution of triangles with various configurations, making it a valuable asset in geometry, trigonometry, and various practical applications. The Pythagorean theorem is a fundamental principle in geometry that relates to the sides of a right triangle. It states that in a right triangle, the square of the length of the hypotenuse, the side opposite the right angle, is equal to the sum of the squares of the lengths of the other two sides. Key concepts. Right triangle. A right triangle is a triangle in which one of the angles is a right angle, 90 degrees. Hypotenuse. The hypotenuse is the side of the right triangle that is opposite the right angle. Legs. The two sides adjacent to the right angle are called the legs of the right triangle. Applications. The Pythagorean theorem has numerous practical applications across various fields. Geometry. The theorem is used to find missing side lengths in right triangles or to determine if a given set of three side lengths forms a right triangle. Trigonometry. The theorem is foundational in trigonometry, used in conjunction with trigonometric ratios to calculate angles and side lengths in right triangles. Distance calculation. In coordinate geometry, the theorem can be used to find the distance between 2 points in a Cartesian plane. Engineering and construction. The theorem is crucial for designing stable structures, such as buildings and bridges, by ensuring accurate measurements and angles. Navigation. The theorem is used in navigation to calculate distances between 2 points on a map when only straight line paths are available. Surveying. It's used to measure distances and create accurate land surveys. Physics. The theorem is used to analyze the motion of objects in projectile motion scenarios.